Of a catalyst, it is the ability of catalyst to increase the rate of chemical reaction by manifold. Like we know that a catalyst increases the rate of reaction. When you use catalyst, the rate of reaction will become high, or it speed up. Now why it happens is because of the adsorption. So if the adsorption is like strong, then the rate of reaction increases, but the attraction or the adsorption must not be that strong, which make your reactant species immobilized, giving no space to the other reactant. Let's take an example of this reaction. If A and B is reacting in presence of catalyst X to give C, if the A affinity or the adsorption rate of A is higher than that B, then what will happen is, so this A will get adsorbed on the surface of the whole space will get occupied by your A. So there will be no space for B. Then what happens? So B won't get space here, means it will not get chance to have reaction with A. So in catalytic, heterogeneous catalytic reaction, so there has to be a medium where your A and B will react and give the product. So this is why the bond or the strength of adsorption, it has not must not be that strong, so that it won't provide any space for the other reactant. So and for example, if you take an example, the hydrogenation the catalytic in hydrogenation reaction, the catalytic property or activity of your catalyst increases from group 5 to group 11. So if you move across the period, the activity of this catalyst will also increase. Okay, and for 7 and 9 the activity is the highest. Now next we will discuss is selectivity of catalyst. Now what is it? So it is again the ability of the catalyst to direct the reaction in a particular way to give a particular product. So let's take an example. It is there in the book also. Just that we have a carbonaceous in all the three cases. Reacting species are same, substrate we are using same, carbon monoxide, hydrogen, but what we are using is different catalyst. Now in first case, if when we are using nickel, we are getting hydrocarbon like methane, water pound. This is second case. Now we are getting copper, zinc oxide, chromium oxide, we are getting chromic oxide, sorry, so we are getting methanol. And when we are using copper, then we are getting methanol. So your see, these are the catalysts which is directing this reaction to a particular direction, giving yielding or giving different products. So this is what we called selectivity of catalyst. ठीक है सर. त्यहाँदेखि स्पेसिफिक पनि हुन्छ क्याटलिस्ट स्पेसिफिसिटी, दो इट्स नट देयर इन बुक. सो स्पेसिफिटी अफ क्याटलिस्ट मिन्स योर क्याटलिस्ट will के अरे will help certain reaction to occur, and the same catalyst we cannot use to bring reaction for some other substrate. That is specificity. ठीक है.